In this video, I'm going to do some examples for cost, revenue, and profit. I'm not really going to go over the formulas because there's a lot of videos that do that, but just in general formulas we will use for this is we will find the profit by doing the revenue minus the cost. And in all the examples we will be given the revenue and the cost function, or we'll be given the demand function. And if I'm given the demand function, I find revenue by taking the number of units times the demand function. And demand function may be in terms of X. A lot of times it's in terms of Q. So it could be Q times D of Q. It just, the number of units times whatever your demand function is, and make sure your variables match. So I pulled a few examples from the Unit 1 packet to do. So the first one we're going to do is this problem, which is under average and instantaneous rate of change in that packet, and it's number 1. So it says given the revenue function R of X, and this is my revenue function, it's defined between 0 is less than or equal to X, which is less than or equal to 1,000. And part A says, what is the change in revenue when production changes from 100 units to 400 units? So all I care about is the change in revenue. So that would just be R of 400 minus R of 100. And something to make this a little bit easier is you can use your calculator to find these. So one way to find this is to plug 400 in for every X value here and then simplify. But to save a little time, you can also use your TI. So what we're going to do is we are going to go to y equals to type our function in. So I'm going to type 20, and then the X is here, minus 0.02 X, and then the squared is here. Okay, so that's my function. And then the easiest way to find these, I generally think, is through table. Before we do that, you want to go to second table set and change your independent to ask. So go over to ask and hit enter. So where I went is I hit second window. Above it says TB SET, which stands for table set. Or sorry, TBL SET, which stands for table set. And that allows me, if I change it, the independent to ask, that allows me to type in any X value that I want and find the Y value under table. So to get to table, you hit this second key and then graph. And then what you're going to do is you're going to type in the X values that you're interested in. So we're interested in 400 and 100. So if I type in 400 here and hit enter, under Y1, it will give me what that R of 400 value is, which is 4,800. So if you can do that, it saves a little bit of time for finding them. And then I would type in 100 and hit enter, and then I get 1,800. But again, you're also welcome to do it the original way if you're not as comfortable with the calculator, where to find R of 400, I would do 20 times 400 minus 0.02 times 400 squared, and then I would type that in my calculator to simplify it. And again, I get 4,800. And then I would do the same thing with 100. Okay, so it's up to you, whichever way you're more comfortable with, but I find the calculator saves me a little bit of time. If you're doing the calculator, make sure you're very careful when you're typing your function in, because if you type your function in wrong, then you're going to get everything wrong with these. Okay, so this is the change in revenue. It's R of 400 minus R of 100. And generally for these, we put units. So the revenue is in money, so it'd be dollars, or you can write dollars after it. Then B says, what is the average rate of change when production changes from 100 units to 400 units? Okay, so average rate of change is the same thing as like the slope between 2 points. So you always take, in general, like the average rate of change is F of B minus F of A. all over b minus a. Okay, in this case, f is r because that's our function. So it'd be r of 400 minus r of 100 over 400 minus 100. Okay, well, the top we just found above, so I'm not going to do it again. I'm just going to put 3,000. And then the bottom, 400 minus 100 is 300. And then 3,000 divided by 300 is 10. Okay, and so the average rate of change gives me that slope of the secant line. If I were to graph it, I'd be finding the slope of the secant line. And for units, it's always the units for the Y value or the revenue over the units for the X value. So in this case, they don't really specify, but revenue is always in dollars. And then my X values are in units. So this would be like dollars per unit. Okay, so that means my average rate of change is $10 per unit. So we have the same function, and then part C is what is the instantaneous rate of change the moment the 100th item is produced. And it says use this limit. Okay, so instantaneous rate of change pretty much means the derivative. And if they don't tell you to use this, then I would definitely use the power rule because it's much shorter. But since they told me to use this definition, I'm going to do this definition. So I'm going to calculate this limit. And then once I find this limit, I'm going to plug in 100 to find the instantaneous rate of change at that exact moment. Okay, so for r of x plus h, everywhere I see an x plus h or an x, I'm going to substitute in x plus h. So I have 20 times x plus h minus 0.02 times x plus h squared. And you can always do this first and like simplify and put it on the side before plugging it into the equation. It might make it a little bit easier. So then I'm going to do minus my f of x. Again, because I have more than one term, I need to put it in parentheses. So I'm going to put 20x minus 0.02x squared. Okay, that's my r of x. And then I'm going to put it over h. So I have the limit as h approaches 0. Again, you have to write this every time until you plug in the 0. I'm going to simplify. So in terms of this first part, I can distribute the 20. So I get 20x plus 20h. The second part, remember, you have to do order of operations. So you have to square it first. Squaring it means you're multiplying it by itself. And so I have to multiply that out. And then I'm also going to distribute this negative here. So I get minus 20x and then minus a negative, which is plus 0.02x squared. Again, this is all over h. So if you have what x plus h squared memorized, it's probably faster to just write that out. But just in case you don't, I will like use FOIL on this. So we multiply our first, which is x times x, so we get x squared. Then we do our outer, which is x times h. Then we do our inner, which is h times x, which is also xh. And then I do my last, which is h times h, which is h squared. Okay, always make sure you do that exponent part first before you distribute. Okay, now that I simplified that, these combine, so xx plus xh plus xh gives me 2xh. So I'm actually just going to put it here to save a little bit of room that I don't have to rewrite this whole thing. Okay, so I combined my like terms there. So now I can simplify a little bit more by distributing this 0.0 or negative 0.02 to everything in the parentheses. So I get minus 0.02 x squared minus 0.02 times 2 is 0.04 xh minus the 0.02 times h squared, which is 0.02 h squared. Okay, then minus 20x plus 0.02 x squared all over h. So I'm still going to write the limit because I'm not plugging it in yet because I still have 0 in the denominator. I need to get that h to cancel out. I am going to combine my like terms. And so what should happen hopefully is all of my terms that do not have an x, or sorry, do not have an h cancel. So this 20x and I have minus 20x add to 0. I have a 20h that doesn't combine with anything. I have a negative 0.02x squared and I have a positive 0.02x squared. So those add to 0. And then I have a minus 0.04 xh and a 0.02 h squared. So none of those combine. So I'm going to rewrite everything I have left. And then the last part is now that I have an h and everything in the numerator, I can cancel it. So again, you can either factor it out and then cancel it, or you can divide each term by h, whichever you're more comfortable with. I'm going to factor it. So I'd have 20 left minus 0.04x minus 0.02h, because I'm only factoring one h out, times h. Cancel the h's. And now I no longer have h in the denominator, so I can plug in 0 for h. When I do that, I no longer need the limit sign. So I'm not going to write it on this step because I'm actually doing that operation. And so that results in 20 minus 0.04x minus 0. So I get 20 minus 0.04x. Okay, so this is my r prime of x, my derivative or my instantaneous rate of change. And then I'm going to plug in 100 because they asked at the 100th item. And if I do that, I get negative 16. So this equals positive 16. Okay. So this is the instantaneous rate of change. Again, the units, whenever do the instantaneous rate of change, are the y units, which is dollars, over the x units, which are just units. So at the 100th item, the rate of change is $16 per unit. So it's increasing by $16. So that's how you find the instantaneous rate of change. Now, again, if they didn't say use the limit, I would definitely just use the power rule because it's a much shorter problem. And on the homework, you don't have to use the limit definition. Okay, so another question. It says given C of x is 10,000 plus 150x minus 0.2x squared represents the total cost of producing x items. How much does it cost to produce 120 items? So if I want the cost for 120 items, I would just plug in 120 into this function. So I would find C of 120. Now, again, you can either plug it in or you can use your calculator and do it like we said before. So either way is fine, but if you wanted to do your calculator again, you would go to y equals, clear what you have in there, and then you would type in the function. So I would type in 10,000 plus 150, and then for x, I use this key here, minus 0.2, and then I hit the x, and then here's the squared. Then I would go to second graph for table. And since I already changed that setting, I don't need to do it again. And I can just type in 120 and hit enter, and it will give me the value. So it'd be 25,120. Okay, and again, cost is always in dollars. So I'm going to put the units. And then B says find the exact cost of producing the 121st item, no calculus here. So if you're not using calculus, you're finding the marginal cost. And to do that without using calculus, you find the cost of the 121st item and you subtract the cost of the 120th item. And that's the change between the two values, which gives me the cost of just producing the 121st item. And again, since I already have it in the calculator, I'm going to just type in the 121 here. Then I don't have to do it by hand. And so that gives me 25,222. And then I'm going to subtract the 120, which is what we got in A, which is 25,120. Subtract those two. Okay, and that gives me $102. And so that is the cost of producing the 121st item. So this next one says C of X, same function, represents the total cost of producing X items. Use marginal cost to approximate the cost of producing the 121st item. So marginal cost is always the derivative, the first derivative of the cost function. Okay, so the derivative of 10,000 is 0. The derivative of 150x is 150. And the derivative of negative 0.02x squared, I bring down the 2 and multiply it by the 0.2. So it's negative 0.4x. 2 minus 1 is 1, so it's to the first power, but we don't need to write that. And then I plug in 120. Okay, so I want the 121st item. C prime of 120 finds the cost of producing the next item. So we're saying we already produced 120 items. The cost of producing the next item, which is the 121st item, is the C prime of 120. So you always do one unit before what they're asking for. So this would be 150 minus 0.4 times 120. And that also gives me 102. And I just want to go back a minute because I realized something. So for this one, it actually on this Y value rounded it. So to get the exact value, which we want to do, you actually have to highlight it. I should have done this for both. So if I highlight this one, the exact value is actually 25,221.8. And then if I subtract them, I get 101.80. So I don't want to round it. So just be careful if you use the table that you actually highlight it to make sure that it's not rounded to the nearest dollar and then subtract it. So this is the more exact cost And then this was the marginal cost. So they tend to be a little bit different, mostly by rounding. But just be careful about that. And if you plugged 121 like directly into this function, you would get exactly the 25,221.8.